Hello class, review for the final. I got just a couple problems here. Given this function in two variables, f of x comma y equals the square root of 3x squared minus y to the fourth, just find this first order partial derivative. So this is read as the first order partial derivative of f with respect to x, or I could write it like this, the partial derivative of f with respect to x. They mean the same thing. So to find the partial derivative of f with respect to x, you might want to pause the video and try it first before you watch the solution. So feel free to pause. Okay, so the first thing you want to do is rewrite this function using a power. We don't like this square root, so rewrite it as the 1/2 power. So put that base in parentheses to the 1/2. So that's the first step. So you want to rewrite like this. Okay, so this is a first order partial derivative. So to take a derivative of this composite function, we're going to need the chain rule. So here we go. So the first order partial derivative of f with respect to x, you bring down this power to get the 1/2 times the 3x squared minus y to the fourth. You keep the base exactly as is. Decrease the power by 1, so 1/2 minus 1 is negative 1/2, and then times by the chain rule the derivative of the inside. But remember, this is a partial derivative with respect to x. We're going to treat y as a constant. This is just a term. Think of this as a constant term. The derivative of a constant term is 0. So just write the derivative of 3x squared as 6x. And then you can do some canceling. The 6 over the 2 simplifies to 3 over 1. And then finally, let's simplify one more step here. So it looks like my numerator is going to be the 3x. And then in the denominator, I'm going to put this base to the negative exponent downstairs to a positive 1/2 power. But because my original function has radical form, a square root, I'm going to write my answer in terms of that idea of a square root. It's nice to have the same form. You know, it doesn't hurt to do that because I know sometimes WebAssign is choosy. Okay, so here we go. The 3x is on top, and then below, instead of writing the 3x squared minus y to the fourth to the positive 1/2 means square root. So if you do it like this, there's no way WebAssign could take off because you have radical form in your answer returning the radical form in the question. That really shouldn't be a big deal if you wrote 1/2 power in the denominator, and it probably isn't. But WebAssign is so picky, you never know, so it doesn't hurt just to be extra careful and have radicals in the end. If they had powers like 1/2 power, then I would have 1/2 power. Just try to return. Okay, let's just do one more problem now. So that problem was only 3.5 minutes. And here comes the next problem. Okay, so more review. Here we go. Evaluate the double integral over some region R of our function in two variables x times y with respect to area, where R is the region bounded by these lines, x equals 1, y equals 0, and y equals x. Here again, feel free to pause the video and try it first. Okay, so whenever I see a question like this, the first thing we should do is draw a picture of this region R. So remember, x equals 1 is a vertical line, y equals 0 is a horizontal line, the x-axis. And then y equals x cuts through quadrants 1 and 3 at a 45-degree angle. So just a rough sketch looks like this. And so there's our region R. So we want to find the volume underneath that surface and above that region R. So now that we have our region R, notice it's not a rectangle. So the order of integration does matter. So what I did was I said, well, clearly this triangle goes from x equals 0 to x equals 1. From x equals 0 to x equals 1, we get that whole base of the triangle. So because I'm using constants, x equals 0 to x equals 1, that's going to be my outer integral. And then the inner integral, because it's not a rectangle, has to have at least one variable endpoint. So to get this whole region, you start from the base, which is clearly y equals 0. So I'm going to integrate from y equals 0, and then when I draw a vertical line parallel to the y-axis, I bump into this line, which is y equals x. So we're going to integrate from y equals 0 to y equals x. That will be my inner integral. And by the way, I could have reversed the integrals, but then my limits would be different. So that's okay too. Here it is real fast. I did it kind of lightly over here. So, or this would work as well. Y goes from 0 to 1, because that's the height of the triangle. And then x would vary from y to 1. So you can think about that. So to me, this one seems more natural the way I did it here. So here we go. Let me continue. Okay, so the rest I'll just do by hand. So I want to find this double integral. All right, so here we go. We're going to say the integral goes from, the outer integral is x equals 0, which is the origin, this is 0, 0, to x equals 1. The constants are the outside integral, constant endpoints. And then my second integral we said was going from y equals 0 to y equals x. Because this is not a rectangular region, we got to have at least one variable endpoint for that inner integral. And then our function is xy. And then instead of writing dA, I'm either going to write dx dy or dy dx. And as you know, it has to be dy dx. Because the integral has endpoint, the inner integral has endpoints in terms of y. So we got to write dy first. And then as I typically do, I like to identify that inner integral as such. So let's do the inner integral here. So the inner integral is going to be y equals 0 to y equals x of xy dy. And this is going to equal, so notice I'm integrating with respect to y. Treat x as if it were a constant. This is a constant factor. So you can pull out the constant factor over here. And if I did do that, it just means it's going to be x times the integral of y dy. So to save time, I'm just going to pull out that x. And then what is the integral of y dy? By the power rule, y to the first becomes y to the second over 2. And then now that we have our integral, we're going to evaluate from y equals 0 to y equals x. And then this is going to equal, so if you want to, you can pull out the x over 2 because those are constant factors, or you can just leave it as it is and input, the y equals x first. You always begin with the upper limit. So I'm not going to pull it out. I could if I wanted to, but I'll just write the x times, instead of writing y squared, y is equal to x. So write x is being squared all over the 2. And then you always go minus, and then you input the lower limit of integration. But when y is 0, this whole thing goes to 0 because 0 is a factor. So whenever 0 is a factor, the product is 0. So I'm just going to write 0. You can do that. And then you want to simplify. So this is like x to the first. Same base of multiplication, you add the exponents. So this becomes x cubed over 2. X cubed over 2. Minus 0 doesn't change anything. And if you want to, this is the same thing. 1/2 times x cubed. I like this way better because I'm going to pull out the 1/2 later. So x cubed over 2 obviously is the same thing as 1/2 x cubed. Now that I'm done with my inner integral, let's go to the outer integral. So the outer integral is right here. X equals 0 to x equals 1. And then we're going to input this 1/2 x cubed. And now it's with respect to x. Okay, we're almost done. I'm going to pull out the 1/2. I'll show my work this time. So I'm going to write 1/2 times, because that's just a constant factor, x equals 0 to x equals 1 of x cubed dx. And that's going to equal, don't forget that 1/2 as part of our answer. And that's going to be multiplied by the integral of x cubed dx is x to the 4th over 4 by the power rule of integration. And now that I have my antiderivative, we're going to evaluate from x equals 0 to x equals 1. You can think of this as like a 1 here. So what's 1/2 times 1/4? That's going to be 1/8. I'm going to pull out that 1/8 constant. So I'm going to write this is equal to 1/8. So that way I just have to evaluate x to the 4th. From x equals 0 to x equals 1. So to me this seems the easiest approach, but you could have not pulled out the 1/8 if you didn't want to. You'd get the same answer. Okay, we're almost done, so I'm just going to continue down here. So this is going to equal, pulling out that 1/8. First you input x equals 1. What is 1 to any power? 1. And then minus, and then we input the 0. What's 0 to any power? 0. Inside the parentheses, 1 minus 0 is 1. 1/8 times 1 is 1/8. So there's our final answer, 1/8. Done. So there is the volume. So we're done with that problem. Okay. Probably you'll see a question like this, by the way. Maximize the function, subject to the constraint. Remember, you always want 0 on one side for your constraint, ultimately. By using the method of Lagrange multipliers. That was on the practice test, the old final exam I put on Learn. So, you should have that formula handy because you're going to need that formula, right? F of x comma y comma lambda is equal to your given function f of x comma y plus lambda times g of xy, where lambda times g of xy is going to be simply lambda times, and this is your g of xy, because if you subtract 9 to each side, you get that. Okay, so I'm not going to bother going over that problem just because you have it in your old final. You got to find the partial derivatives, etc., etc. Let's see, is there anything else I want to do here? Yeah, that should be good for now. This is already going on 13 minutes. So good luck, everyone, and the semester is just about over, so finish strong. Bye-bye.